Hey guys, since a lot of you weren't here, whether it was because of HIP or Panther Fur Day or the civics test or the pep rally or whatever, I'm going to do a video for 7.2 just to make sure everybody's caught up, because next class on Monday or Tuesday you do have a quiz for me. So last time in 7.1 we were dealing with sampling distributions. We did an example where you had a lot of sample, you had like these 10 samples of somebody's quiz scores, and then we found a whole bunch of sample means, right? And then we graphed those sample means on a number line, right? I think it went from like 85 to like 93. Okay, and we plotted those X bars on a number line, and that was our sampling distribution. Today we're dealing with the same idea, except today our sampling distribution is going to be, instead of sample means, it's going to be about sample proportions. So it's going to be p-hats. That's why in this example right here, okay, all the little dots, like this would be a dot, are a bunch of little p-hats, a lot of sample proportions. Okay, so kind of like when we were talking about binomial distributions, when our sample proportion is small, like 0.10, all of our data is going to be like on that small side. Okay, when our proportion is 0.9, all of our data is going to be centered around 0.9. Okay, and when it's kind of 50-50, it's going to be in the middle. Okay, kind of symmetric. Okay, so down here in your notes, when n is small and p is close to 0, so that's this guy over here, right? P was close to 0. The sampling distribution of p hat is skewed to the right. When n is small and p hat is close to 1, so that's over here, the sampling distribution of p hat is skewed to the, look over here, it's skewed to the left. All right, and when the sampling distribution of p hat becomes more, we're going to say symmetric, when p is closer to half, like it is here, right? It's close to half, so this is looking pretty symmetric. Okay, or the sample size is getting larger. So if you look here on the bottom, those are all samples of size 100 instead of, 25 like we have on the top. And the bottom, they all look pretty symmetric. They actually look a little normal, but we'll talk about whether or not it's normal in a little bit. So we'll say for sure symmetric. Excuse me. So the center of them, okay, the mean of our sampling distribution, remember how I said a second ago, let me erase all this just to highlight it again, okay? If my p is 0.10, all my data is kind of centered around that. When my p was 0.50, it was kind of centered around it. When it was 0.90, it was kind of centered around 0.90. The mean of your sampling distribution for p hat is going to just be p, excuse me, whatever it is in the population, okay? For variability, for the standard deviation, the value of the standard deviation of your sampling distribution of p hat, it depends on the sample size and the probability. So for a specific sample size, the standard deviation is large, okay, when values of p are close to 0.5, okay, and it's going to be smaller for values of p that are close to 0 or 1. Excuse me. Okay, so basically what it's saying is there's more spread here because it's close to 0.50 than there is here because it's close to 1, or here because it's close to 0. All right, so long story short, we just wrote this down. The mean is just going to be p. Our standard deviation is right here. If you do not want to remember that, that's okay. This is in your reference sheet. Okay, it's on the back, on the top of the back of the first page of your reference sheet. Excuse me, I'm still sick from before. But anywho, if you guys see this, my sample size is in my standard deviation. So the bigger the sample size, the smaller the standard deviation is going to be, because you're dividing by a bigger number. Okay. Now, we also mentioned back in chapter 6, we briefly talked about this, but we talked about the 10% condition. I'm just going to remind you what that is. Okay, it's right here. It's saying this little n is less than or equal to, I'm used to it just being less than, 10% of big N. What does that mean? That means my sample is less than 10% of the population. Okay. So we're going to do that to make sure that our values are independently chosen. Okay, what does that mean? Technically, when you pick names out of a hat, so make sure everyone has the same chance of being chosen, you're supposed to put the names back in the hat after you pick them. Realistically, nobody does that, okay? When you pick a sample, you don't put everybody back in the running after you pick them. So to make sure that the difference in those, chances of being picked are negligible, we need to have a small enough sample size that our sample is less than 10% of the whole population. So the 10% condition, again, this is for independence. Okay, now we have this other one called large counts, which we didn't do too much of, so I'm going to tell it to you now again. Okay, large counts, this is for normality. Basically, we're going to do our sample size times our probability, and the sample size times 1 minus the probability. They both have to be at least 10. Okay, if they both are at least 10, then it is going to be, in fact, normally distributed. Okay, and that's important because we want everything to be normally distributed. Okay, because then we get to use normal CDF for things. Excuse me. All right, so let's do an example. Suppose 84% of students at a large high school regularly use a backpack to carry their books from class to class. Imagine taking a simple random sample of 100 students and calculating p hat, the proportion of students in the sample who regularly use a backpack. All right, identify the mean of the sampling distribution of p hat. All right, the mean of p hat is just going to be p, which in this case was 84. 0.84, that's it. All right, calculate and interpret the standard deviation. So standard deviation is going to be p times 1 minus p over n. So that's 0.84 times 0.16 over, what's our sample size? 100. Okay, let's see. I need to plug that in myself, so let's see. All right, so we get the standard deviation is 0.0367. It says interpret and verify the 10% condition. So interpret, on average, the sample proportion is about 0.0367 away from the true proportion of backpack users. Okay, and that true proportion was 0.84. All right, and it did say verify the 10% condition. I don't know how big the school is. It does say it's a large high school. So I'm just going to assume 100 is less than 10% of all students at the school. Okay. So most of the time, that 10% condition is going to look like this. It's going to look like an assume type of sentence. All right, last piece, part C. Describe the shape. Again, the only shape we care about is normal. So we're going to do large counts, n times p, see if that's at least 10, and n times 1 minus p, and see if that's at least 10. So my sample size was 100 times 0.84. That's easy enough. And then 100 times the complement of 84%, so 0.16. They are both at least 10, so this is going to be approximately normal. Okay. And it says justify your answer. That work is enough justification. You don't need to do it again. Or you don't need to write any sentence or anything. That's it. All right, let's keep going. Do another one. A polling organization asks a simple random sample of 1,500 first-year college students how far away their home is. Suppose 35% of all first-year students attend college within 50 miles of home. Find the probability that the random sample of 1,500 students will give a result within 2 percentage points of the true value. Okay, they didn't tell us to check conditions, but we're always going to check conditions. So I'm going to do n times p and n times 1 minus p to make sure that it's normal so that I can find the probability by using normal CDF. So my sample is 1,500. My probability is 0.35. All right, and then my sample size again, 1,500, and then 1 minus 0.35, 0.65. All right, so 1,500 times 0.35, we get 525. That's bigger than 10. And then this would be 975, also bigger than 10. So we do, in fact, have a normally distributed problem. So eventually, we'll be doing normal CDF. Okay, I need to do the 10% condition, so I'm going to assume 1,500 is less than 10% of all first-year college students. Okay, and then now I'm going to go in with normal CDF to actually solve the problem. All right, so normal CDF. Now I need the mean. The mean is easy enough. Okay, it's just going to be p, so it's just going to be 0.35. All right, standard deviation, I got to do a little bit of work. It's going to be 0.35 times 0.65 over my sample size of 1,500. That's a large sample size, so it's probably going to be a pretty small standard deviation. 0.35, 0.65. Oh, let's keep 0.0123. So my standard deviation is going to be 0.0123. All right, now for the high and the low, it said it's going to be within 2% of the true value. What's the true value? True value is p. It's 0.35. So 2% lower than 0.35, my low is going to be 0.33. 2% higher than 0.35, my high is going to be 0.37. Okay. And then that's it, and then I just plug it into my calculator. I go into second vars, normal CDF. I type everything in the exact way you guys see it. And we get 0.8961. That's it. Okay, so on your quiz next time, you're going to have one problem that looks very similar to this, except you don't have to check conditions. So it's just going to basically be this work right here. Okay. Now, the other problem, it's going to deal with two populations. So like here, okay, we have school 1, 70% of kids did their homework, so I have P1 equals 0.70. School 2, only 50%. So P2, because it's school 2, is 0.5. We have simple random sample from school 1. So we have the sample proportion, P hat 1, because school 1. And then we have a sample random sample from school 2. So they'll use P hat 2 for for that sample. So what are we going to do with this? Just like we did in chapter 6 when we did things like, Andy minus Bob or Margie minus Bill or something like that. Okay, we're going to combine the two distributions together. And just like before, we needed both distributions to be normal for us to use normal CDF. Same thing here. So for shape, okay, what we're going to do is we're going to check large counts for school 1. And we're going to check large counts for school 2. Because if they both pass large counts, that means they are both normal, and that means the combination of them will also be normal. Okay. Center. You just find the mean for both of them, and that should be pretty easy. Okay, the mean for the first group will just be whatever the population proportion is for the first group, in this case, 0.70. The mean for the second sample is going to be whatever the population proportion is for the second sample, so 0.5. Not much to do there. Now, variability, technically, okay, when we combine two groups, right, like means, it was pretty straightforward. If it was adding, you add them. If it was subtracting, you subtract them. Standard deviations, you would have to square them, add them, square root them. While that technically is still true, I'll show you the one formula that you can use in this case so that you don't have to find two standard deviations and then square them, add them, square root them. But what you do need to do is check the 10% condition for both. Okay, so check the 10% condition for school 1, and check the 10% condition for school 2. Okay. Now, all this lovely, beautiful picture means is that each of these dots is no longer a P1 hat or a P2 hat. Each of these is what happens when you subtract P1 hat and P2 hat. So in one sample from school 1, we get 0.72. In a sample from school 2, we got this. So when we subtracted them, okay, we get 0.25. That's the dot that we're plotting now. It's the difference between the two. Okay. Okay, so kind of to recap, we're going to check that everything is approximately normal. So we're going to have n times p for the first group and n times a complement for the first group. We're also going to have n times p for the second group. That's why there's a 2, and n times p and the complement of p for the second group. So we're doing large counts for both. Like I said, the mean, you're just doing exactly what you think you're doing, so you're subtracting the 2. We are doing 10% for both. And here is our new standard deviation formula. Now, again, don't freak out about remembering it because it's on your reference sheet. But if you look at it, it looks just like the one for a single population. Okay, like here's p times 1 minus p over n. And then there's another p times 1 minus p over n. Okay, you just have both for both populations. You add them and you have a big square root on top. Okay, but again, it's on your reference sheet if you forget them. Okay, the whole point of the 10% thing is to make sure that we have independent observations within each sample. Okay, like again, that it doesn't matter that we didn't replace them. Okay, that they're approximately independent from each other. Okay, we also need to make sure that each sample is independent from each other. School 1 had nothing to do with the stuff from school 2, and vice versa. All right, last example, let's just do this. It's not that complicated. So your teacher brings two bags of colored goldfish crackers to class. Bag 1 has 25% red crackers and bag 2 has 35% red crackers. Each bag contains more than 1,000 crackers. Using a paper cup, your teacher takes a simple random sample of 50 crackers from bag 1 and a separate simple random sample from 40 crackers from bag 2. Let P1 hat minus P2 hat be the difference in sample proportion of red crackers. What is the shape of the sampling distribution? Okay. The only shape we care about is normal. So I'm going to make sure N1 times P1 and N1 times 1 minus P1. Those both have to be at least 10. So we have our sample sizes are 50 and 40. So we're going to do with 50 first. So this 50 goes with this 25%. And then the 40 goes with the 35%. So 50 times 0.25, that's going to be 12.5. That's bigger than 10. And then we have 50 times the complement, 0.75, 37.5. Okay, they're both bigger than 10. We're going to go with N2 and P2. That has to be at least 10. So 40 times 0.35, that's 14. And then N2 and the complement of P2. So 40 times 0.65, which is 26. They are all at least 10, so that means that's approximately normal. Okay, so that means when they ask us to find the probability, we can use normal CDF. All right, find the mean of the sampling distribution. So the mean of P1 hat minus P2 hat is just going to be P1 minus P2. So 0.25 minus 0.35 is negative 0.10. That is our new mean. All right, standard deviation. So they ask us to calculate and interpret it. Technically, they didn't ask about the 10% rule, but I'm going to do it just to like get that in our brains. Okay. Now, usually we'd write assume that our sample is less than 10%, but I know my population size. So I know 50 is less than 10% of 1,000. And I know 40 is less than 10% of 1,000, because 10% of 1,000 is 100, and 50 and 40 are both less than 10%. They're both less than 100. All right, so I just wanted to make sure we got that 10%. So let's calculate the standard deviation. So my new formula is just going to be, so P1, which is 0.25, times its complement, 0.75, over the sample that it came with. Plus, and now P2, 0.35, times the complement, over its sample size. Okay, where did I get those? That came straight from this formula right here. Okay. So, square root. So you can type it in exactly like that. I'm just doing square root 0.25. I'm not putting parentheses, I'm putting the times symbol, 0.75, divided by 50, plus 0.35 times 0.65 over 40. So my standard deviation is 0.0971, which means on average, now this isn't going to be just the sampling proportion, this is going to be the difference, because we're subtracting two of them, the difference in sample proportion is about this far away from the true difference in proportions, which we found earlier was negative 0.10. Okay. Now part D, estimate the probability that the red crackers from bag 1 is greater than the proportion of red crackers from bag 2. Okay, probability. I know it's going to be normal CDF because we already proved it was normal. Okay. I know the mean, we already said, was negative 0.10. I know the standard deviation, we just found it, 0.0971. Let me try to separate it a little bit. Okay. Now the only thing is the low and the high. So they say, excuse me, they said bag 1 is supposed to be bigger than bag 2. So if that's the case, if I need bag 1 minus bag 2, okay, that means it's going to be greater than 0. Okay, bag 1 is bigger, so let's do it a different way. If bag 1 is bigger and bag 2 is smaller, big minus small is going to have to be positive answers. Okay, so whichever way you look at it, I need things greater than 0. So 0 is my lowest, and positive infinity is going to be my high. So that's what I'm going to plug into normal CDF from 0 to infinity. Remember, just type in like a really big number, like 99999 or something. Not 0.9, but 99999. My mean will be negative 0.10. Make sure as you type in the negative that you type negative, not minus. And I type in my standard deviation. We get 0.1515. Okay. On your quiz, you're going to have a problem like this, where it's two proportions. Okay. They're probably not going to have this question. It'll just say, what's the probability? It's not going to tell you straight up, but I'm going to say, make sure you check conditions. So you're going to need to check large counts. Okay. You're going to need to check for independence with the 10% condition. I'm not telling you straight out and obvious that you have to find the mean, but you're going to need the mean to do normal CDF, and you're going to need standard deviation to do normal CDF. So while you don't have to find them as obvious like this one, like I said, part B, find mean, part C, find the standard deviation, you do have to do it to do normal CDF. Okay, now that's it for the notes. Okay. What I will say is please make sure that you go on to Schoology and you check the 7.1 and 7.2 quiz review that I left for you. Excuse me. I put 3 questions on that review that look very similar to the 3 questions you will have on your quiz. So please make sure you do those questions. I will spend about 15 minutes or so before the quiz going over things with you guys. Okay, so maybe if you have any questions on those things, I'm happy to go over them. But everything we've talked about today, okay, is on that quiz, and everything that we talked about, or rather everything that is on the review, we just mentioned today, okay? So just to recap, for means, it's just whatever the probability is that was stated from the population. If we're doing 2 populations, you are just going to subtract the 2 in the order that they were that it was told to you. Standard deviation, just follow the formula. Okay, make sure you do large counts if they told you to. Large counts is n times p and n times 1 minus p. You have to do it for both populations if there are 2. You have to do 10% condition. So make sure my sample is less than 10% of the population. If you have 2 populations, do it for both. Okay, and then when they ask you to find the probability of something, hopefully you already proved it was normal. So you're going to do normal CDF using the mean and standard deviation you just found. Read the question, make sure you get the right low and high, and that should be it. Okay, again, if you have any questions, let me know on Monday or Tuesday when I see you guys before your quiz. Otherwise, I hope this was pretty easy for you. All right, see you guys later.